Hello, my microeconomics students. I wanted to help you do well by reviewing these answers, and maybe I can point to some of the common pitfalls of this as well. I'd also like to call your attention to the study sheet questions. This sheet, which I've made for you along with the definitions down below, is really a sheet that I created based upon this PowerPoint presentation that we're watching, or this review sheet that we're looking at here. So, in an experiment, children were given a marshmallow and were promised a second marshmallow if they could wait 15 minutes to eat the first one. About only a third of the children actually earned the second marshmallow. This experiment is an indication of inconsistent intertemporal decision making, also known as hyperbolic discounting. Now, I might ask a similar question on the test, or I'll ask a question that has framing effects as the answer, priming effects as the answer, or status quo bias as the answer. So the scenarios change, but the answers often are the same choices. You want to be able to think of the what I might have asked to get one of these different answers. This next question has two similar groups of people. One of them, in one group, they answered yes by 75% of one group and only 50% of the other group. What might have happened? Well, it must have been with the priming effect. Something about the order of the questions was key. Next question. Darius is offered a choice between two gambles. If you have 110 payoff with either heads or tails, then the value or expected value of gamble number one is $110. On the other hand, gamble number two, where you win 120 half the time, means that part of the gamble has a $60 value, and then you earn $70 the other half of the time. That's worth a $35 value. 60 plus 35 means the value of this game, or expected value of this game, is $95. And since Darius chose to play a game that has an expected value of 95, he behaved like he preferred that $95 value was preferable to $110 value. The only thing that explains that is that he acts like he doesn't know the odds. And if he acts like he doesn't know the odds, then he is either a risk taker or risk averse, because risk neutral people act like they understand the odds. Risk takers and risk averse people do not. In this case, we know that Darius is a risk taker because there was a chance of winning more than 110, and that's why he chose to do that. 50% of the time, a lottery ticket pays $1,000. Since it only pays out half the time, then the expected value of the gamble is $500. Sean's buying a lotto ticket for a Fantasy 5 game in which players try to predict which 5 numbers will be drawn of the numbers 1 through 39. Since the number 17 hasn't been drawn in the last 60 days, Sean feels it's due to be drawn and therefore is a good number to be bet. Sean right? Fill in the blank to complete the message. Nope, Sean is incorrect. This is an example of the gambler's fallacy. Sean believes that the number 17 is overdue. The fact is, recent history makes the number 17 equally likely to be drawn compared to other numbers. Moving along to this next one. Aku pays each worker $50 a day. What's his marginal profit for the fourth employee, ignoring the added cost of raw materials? Well, part of your question was sliced off, so I'm going to fill in some blanks. We're going to say that the price of paint when we sell it, Akua sells it as $30 a gallon. We're also going to assume, just for the sake of the argument, that there's no marginal cost of materials for the paint. It's only labor that's being considered here. And we're going to say that the amount of gallons that are being produced at 44 gallons is with 3 employees. With the fourth employee, they'd be able to increase output to 48 gallons. So that means the marginal productivity of labor is 4 gallons. Since each gallon can sell for $30, the marginal productivity of labor has a value of 4 gallons times $30 or $120. The marginal value of labor is $120, but the cost of that fourth worker is $50, so the marginal profit is $70. That's how you calculate that kind of problem. You should make up some of your own problems there and try to see if you can anticipate the marginal value. Like for instance, at work, if you have a job or if you know someone who next time you're in a place where they look like they have a marginal worker, try to decide what that worker is adding to the productivity of the operation and think about how much that person is costing the operation. Try to decide whether that person is a liability or an overall asset on the organization. It's always good to point that that lens at yourself as well. Here I've made some notes. Katie, we're trying to figure out whether the following scenario could lower a firm's demand for labor. Here I'm suggesting that the demand for labor would be increased. Here the demand for labor would be decreased. Here the demand for labor would be decreased. Here the demand for labor would increase. And here the demand for labor would decrease. So if I were to ask this question, label them A, B, C, D, E, and I was looking for something that would lower a firm's demand for labor, then the correct answers would be B, C, and E. And it's totally fine for you to mark a scantron with more than one bubble if that's the correct answer. It hurts the economy when employees lose their jobs because of technology. False. Only Luddites believe that. Stefan owns a shirt factory. He sells each shirt for $50. Previously, he had 30 employees producing a total of 300 shirts daily. Then Stefan added 10 new employees and noted that production increased to 350 shirts per day. Calculate the value of the marginal product in the range of 30 to 40 employees. So what we can do here is see that the marginal productivity of labor is 50 shirts. That is to say that by adding 10 more employees, 50 more shirts were being added. Since each shirt is worth $50, that's $2,500 in marginal productivity of labor. Now if we wanted to divide by the 10 employees, that would work out to an average of $250 each, or if we wanted to calculate it as daily, that it's the marginal contribution is $2,500 per day for this unit of labor, which represents 10 employees. So the wording on this is such that I interpret it that we are looking at for between 30 and 40 employees, each employee adds $250 of value. But if I had asked the question slightly differently and we were looking for one unit of labor is 10 employees, then 10 employees is equal to $2,500 marginal product of labor. So the marginal benefit of 10 workers is $2,500 daily. So moving right along, we have a couple different choices: intertemporal decision making, framing effects, priming effects, and loss aversion. And Wayne has a good salary, wants to have a comfortable retirement, but always seems to spend his entire paycheck and never saves it. That is intertemporal decision making. A survey about the weather first asks respondents how often it has rained, and then asks them if they believe there's been a drought. That is, of course, the priming effect. And lastly, a driver is reluctant to get rid of a car that turned out to be a bad buy, even though she could then buy a better one. And that's loss aversion. It's painful to admit that something is lost. Kind of a fallacy of the sunk cost, right along with loss aversion. Shoshana owns a hair salon. She starts with one employee and hires a second week after she opens. Shoshana notices that after hiring the first and second worker, her total output increases, and her marginal profit from each of these two employees is positive. Now, to say it's positive means like the first employee may have brought in an extra $500 in profit, and the second employee might have brought in an extra $120 in profit. They're both positive, but it's on a declining piece. It doesn't tell us what happens. We only know that it's positive. Will it always be beneficial for Shoshana to continually hire more employees? No. At some point, adding more employees falls into the law of diminishing marginal productivity. Match each term to the situation it describes. Well, here we have the income effect and the substitution effect. Let's see which one is going with which. So Steve notices that most of his employees choose not to work overtime. That is what we would call the income effect. Eddie feels he earns enough money and decides to cut back on his hours. That is also the income effect. After a raise, Carla sees her part-time job as more worthwhile and asks to work more hours. That's the substitution effect. Amy decides the opportunity cost of taking time off work is too high for her. That's the substitution effect as well. Paul earns $90 an hour as a landscaper and usually works 8 hours each day. Paul's employer offers him a $5 per hour raise if he will work his normal hours this Saturday. He's considering taking the day off to rest. What's Paul's opportunity cost of taking the day off from work? $760. $90 an hour becomes $95 an hour on a Saturday. 95 times 8 is $760. That's his opportunity cost. Next one. Here I've labeled them C, B, and A only to correspond with what we have down here. Millions of college students graduate from school and begin looking for jobs. That is an increase in the supply of labor. The working age population of a state remains steady throughout the years. That means nothing moves on the labor curve, the labor supply curve. So here's B is the labor supply curve that doesn't move. This is the labor supply curve that shows an increase in labor. At every wage, there's more workers available. And over here at C, shows that every wage, there's fewer workers available. And that one possible explanation would be C, a city has an aging population so that more people retire each year than enter the workforce. And so you have fewer and fewer workers in this labor department. Some countries are experiencing that, like Japan. Germain's boat factory recently outsourced its boat production from City A to City B. What could be a short-term consequence of outsourcing production? Well, wages will increase for boat manufacturers in City A? No. If anything, wages will decrease. Wages will decrease for boat manufacturers in City B? No, it's actually going to be an increase for wages in City B because there's more business in City B, less in City A. Consumers will have less buying power in City A. No, that won't happen either. Probably prices in City A will drop and consumers will have more buying power because of lower prices. Workers who worked in City A's boat factory will be unemployed. True? That's true. Moving right along. What types of wages is a monopsonist likely to offer? Now, you've probably learned that a monopsonist is in fact a single buyer. So when there is a single buyer, the demand for labor is low. A monopsonist is more likely to offer lower wages because there is no other firms competing for the workers' labor. The presence of a monopsonist decreases the demand for labor. When will there be a labor surplus? Order the industries below from most likely to have a surplus to least likely to have a surplus. So we'll actually have a shortage if in Industry A, where firms need to quickly bring all jobs back from overseas after outsourcing led to a quality concern. The problem is, of course, a shortage of workers because there's a plethora of jobs that have come back and not enough people to fill them. So a shortage in the labor market. Over here, Industry B, there's equilibrium, and Industry C, where new regulations have led to expanded employee benefits and high wages, leads to lots of people wanting to work in Industry C and not as many jobs being created in Industry C, so we have a surplus of labor in Industry C. A plot of land close to the beach could earn its owners $300 a day as a parking lot or $500 a day as a campground. Calculate the weekly economic rent of using the land as a campground. So the formula for economic rent is take the highest and best use, value 1, subtract the second best use, value 2, and that gives you your economic rent. $500 that you make minus the $300 that you could be making gives you your economic rent of $200. What is the status of the supply of labor for each of the following industries? Match each situation to the supply of labor that likely exists for that particular industry. So what I have indicated is that there's a shortage in both the top and bottom scenario and a surplus of labor in the two middle ones. So what is it that's causing a shortage of labor and therefore like more jobs than there are people to work them? Fast food restaurants pay minimum wage and do not offer significant raises. That's going to mean a shortage of labor. Not too many people working, lots of jobs, openings. Down here too, a university ceases to offer full scholarships for middle school teacher education programs. That means there'll be fewer middle school teachers, and there'll be a shortage of middle school teachers due to this change in policy at the university. On the other hand, a surplus of labor, well, there'll be excess people for the number of jobs. There'll be more people than jobs is when a hospital increases the number of training programs available to new doctors, and when universities decide to increase the wages offered to math professors. There'll be more people trying to be math professors than there will be positions, and that's what we call a surplus. Or there'll be more doctors than there will be a need for doctors, and that will be a surplus as well. Companies usually outsource because they can save money by using lower cost labor. True or false? That's true. What might delay a market's return to equilibrium if there's a shortage of workers? Correct answers include it may take several years to train new workers to join a particular industry, and it may take several years for wages to increase to entice workers to join. Both of those things would delay a market's return to equilibrium. However, you'll reach equilibrium very quickly if the wages are very high, or if there are no job openings in the field, then you will a shortage of workers will be corrected very quickly. You'll find that the equilibrium will get there rapidly. Amanda needs to buy a new car for work. She has one day to find a car and was able to read only one article about new cars before she went to the dealership. Which of the following options describe how bounded rationality is at work in this situation? Amanda feels pressured by the time constraints on her purchase? Yes, that will be an example of bounded rationality. So is Amanda has a limited amount of information with which to make her decisions. Also bounded rationality. Amanda does not want to buy a good car. That's not true, nor is it, it's not an example of bounded rationality. And Amanda did not make an effort to gather. Well, that's not true either. She read one thing. She didn't have time to read more. The fact that she only read one thing was an example of rational ignorance. You've been entered in a free game where you try to guess the roll of a six-sided die. You'll win $60 if you guess right. What's your expected payoff value? You got a 1/6 chance of winning $60. So 1/6 of 60 is $10. Answer. Use bounded rationality. Identify the reason why in each situation a consumer might fail to make the decision that rational models predict. You have limited information, capacity, capital, and time as your possible choices. Gwen's car is running out of gas. She stops at the first station she sees. Limited time. Riley has been shopping for a new laptop for weeks. At this point, he's having trouble distinguishing the different models he's seen. B. Limited capacity to process information. His head is swimming. And Armando is shopping for shrubs for his yard. He's tried unsuccessfully to find out which shrubs are the most disease resistant. A. Limited information. There's not the information that he needs is not fully available. All examples of bounded rationality. Various examples that were good. Jamie mailed in a raffle entry off the side of a cereal carton. The carton said that 1 in 800,000 entries would win. Which of the following is a rational motivation for Jamie to enter the raffle? Well, the raffle has a positive expected value. Whatever the 1 divided by 800 gives you a very small percentage chance. You take that percentage chance, multiply it times the winning, whatever the prize is worth, and that would be the value of the piece. Like, for instance, if he was going to win $400,000 as a winner, then the value of that would be about 50 cents. So Jamie has never won a raffle before, so he is likely to win this time. No, that's not a rational way of thinking about it. Jamie has a good chance of winning. No, it's not a good chance at all. A very slim chance. That's not a good way of thinking. Both of those are either the hot hand fallacy or the gambler's fallacy. In the case of gambler's fallacy for choice B, and just a bad understanding of math for C. Jamie often wins raffles. No, that's not rational either. That's an example of the hot hand fallacy. True or false? For a company which has a 401k savings plan for its employees, the participation rate will be about the same whether people are given an easy enrollment form to fill out or enrolled automatically, but given an easy opt-out form to complete if they don't want to participate. And that is false. Research has shown that when you have an opt-in program, that fewer people will opt in. And if you have an opt-out program, then more people will stay signed up because it's more trouble to fill out the form to opt out. So if you want people to participate, have them opt in. Kind of like our HVCC's parking program. If you don't have a car, you can fill out a form and opt out. Otherwise, you're in and paying the fee. Mary decides not to leave her current minimum wage job for a higher paying job. She knows the ropes at her current job, knows how to deal with her coworkers. She fears having to adapt to a new situation and getting to know a new set of people. What inconsistency in decision making might cause this? Fill in the blanks to complete the passage. Mary could be exhibiting status quo bias because she wants to maintain her current work environment. Mary values keeping her current wage and familiar coworkers more than the opportunity to enhance her welfare. This is an example of loss aversion. In this scenario, traditional economic theory assumes Mary would choose to accept the higher paying job. The field of economics that helps us understand why people's decisions sometimes contradict standard assumptions about rationality is called behavioral economics. Anakin is given 3 choices. Pay $100 for an 80% chance to win $400. 80% chance of $400 has an expected value of $320. 30% chance of winning $600 has an expected value of $180, because 30% times 600. And a sure thing payout of $300, of course, has an expected value of $300. If Anakin is a risk-neutral gambler, which way will he choose? And since the payment is the same, $100 gamble no matter what, all you have to do is look at the expected value to see which one is the best piece. If he takes the 80% chance of $400, that's your risk-neutral choice. If you go with the sure thing of $300, that would be an example of a risk-averse person, because the risk-averse person is acting like they don't understand the odds because they're choosing a lower value option that has a guarantee piece to it. And then the risk-loving person chooses something that is they're showing like they don't understand the odds either. They're choosing a lower value gamble because it looks like there's a chance to win big. So Jorge considers himself a risk-averse person. He takes the opportunity to switch to a new job, where there are 2 possible outcomes. He has a 20% chance at the new job that he'll earn $30,000 more per year than his current job, and there's an 80% chance he'll get laid off and end up in a job where he's earning $10,000 less than in his current job. What does this decision tell us about Jorge? Well, if we evaluate this, there's a 20% chance of $30,000 more, so that's a positive $6,000 value, and an 80% chance of losing $10,000, so that's an $8,000 negative expected value, plus $6,000, and a negative $8,000 yields an overall expected value of the new job as being $2,000 less than the other one. But because Jorge, despite him saying that he was a risk-averse person, he went and took a job that had a lower expected value, that tells us that Jorge's assessment of himself as a risk-averse person is incorrect. He's actually a risk-taker. And let's go to this one. The probability of winning 80% payout of 1,000 is worth 800. Probability of winning 50% payout 5,000 is worth 2,500. And the probability of winning 15% chance of winning a $10,000 prize is worth 1,500. So the expected value of the following games is, this one is the least value, this one is the second least value, and this one is worth the most, or the best. And then finally, I just have some notes here from today's discussion. I show how the demand schedule is put together. Let me see if I can. There we are. So what we have here is the demand is the measure of desire in the marketplace. I've got you can take screenshots here, or I like to use this thing called what is it called? I don't remember. It's called clip or something. Snipping tool. So if you add that on there, you can just take it and clip it, and then you have it and you can save it. Anyway, folks, thanks a lot. I hope you enjoyed it.